Good afternoon, everyone. Can you hear me okay? First of all, I would like to thank Aapresid for this space. To us, it is a great achievement to be here today and be able to talk to you. I would like to thank all of you present here. I know that it's late, and let me assure you that this is going to be a very interesting panel. My name is Juan Culpian. I am at Bidcom Agro, technical sales manager, and Bidcom Agro belongs to Bidcom Group, a technological leading company in Argentina. We are the DJI master dealers for more than 10 years in Argentina, Uruguay, and Bolivia. And we are also official dealers of DJI Agriculture in Argentina. We are ag tech specialists. We have a very solid network of resellers in Argentina, especially resellers in the center and the south of the country. And also, we have the brand machinery line, and we are very proud of having it. Our network has two main pillars that I find very important for the company. The DJI Academy, which makes our resellers being flight instructors, and we also have the customer or technical service leg. Today, all of our resellers are certified for after-sales services, training, and delivery of the equipment from the beginning and support up to the moment where it is delivered. Also, they are committed to instruction and training. Now, we're going to give the floor to Valentin Nicola, who will make an introduction of the Agras T100, and he will compare it with the model T50. Also, we have here today our resellers, which are very experienced, who have been testing a lot, and we will presenting two success cases. So, Valen, you have the floor. Hi. How are you? I am the technical development head at Bidcom, and I am going to present the story of DJI Agriculture. DJI has more than 400,000 drone operators, more than 400 drones used all over the world, or 400,000 in more than 100 countries and regions. And this is DJI's timeline. It started working with drones, especially for applications, with the MG1 model in 2016. Throughout time, the model got perfected. And with this timeline, you can see all the different models that they launched. And there was a turning point with the T40, with the spraying system was changed. They moved from pills to a centrifuge system. In 2024, the T50 model was launched, and today, in 2025, we are launching the new product, the DJI Agras T100. So let me give you a brief introduction about the T50 for those of you who don't know it. The model called T50 is for applying liquids. It has a labor capacity of 21 hectares per hour, and in case of solid spreading, 1.5 tons per hour. And of course, this data will be modified according to the number of kilos that we want to spread. So about the T50, the spraying system and the spreading system, we need to talk about the tank that the T50 has, which is 40 liters, with a flow capacity of 16 liters per minute, with 2 sprayers. If we're going to add more and have 4 sprayers instead of 2, then this flow will move to or grow to 24 liters per minute. And the detail about the system is that the droplet size can be regulated from 50 to 500 microns. And we have also solenoid valves. And with regards to the solid spreading tool, it has a capacity of 50 kilos. It will depend on the side of the seed. And the system has a hinge and a dosage plate that will distribute solids, fertilizers, seeds, whatever. With regards to Agras T100 and its security system, this is a drone with 2 radars, one at the front and one at the back. And it also has 2 binocular pairs. And if there is lighting, these binoculars will act in order to avoid obstacles. One more thing to share about this is that we can make mappings if we have an RTK antenna. This is very useful for working in mountain areas. The technology is very good, for this mapping. For orchards and high areas. So, in terms of energy source, it has a smart battery, a generator, and a wall charger. Here, as you can see on the video, there are some hoses here in the battery for its cooling, the generator that will offer the power. You can see here how this is installed. And then there are some coolers that will allow this battery to cool. So that is the wall generator. And yeah, I think that we are all here to see the T100, right? I believe that there's going to be a before and after this drone in the agricultural sphere. It has a 100-liter liquid tank, a spreading tank with a 100-kilo capacity, an elevation system. This is very new, an elevation system that can transport 100 kilos, double spraying, a security system which is very avant-garde, and a charger such as the T50. With regards to the spraying of liquids, as we have just said, it has a 100-liter capacity in the tank, a flow rate with one only nozzle of 30 liters per minute. You can add another pair of nozzles, which would take it to 40 liters per minute. And as with the T50, we can adjust the size of the droplet from 50 to 500 microns. And in turn, this model has a separate spraying system that can take droplets from 10 microns to 500 microns in size. And this is a positive change with regards to the solid spreading design. We have a channel or conduct that takes to a plate the solid that we are operating. And this is feeding the plate permanently, which generates a constant flow, and this is exchangeable. We have different sizes, extra large, large, medium, and small, according to the size of what we are trying to spread. With regards to the security system, we have a lot of progress here. This is the first drone by DJI Agriculture with a LiDAR radar. There is a front, a medium, and back radar with millimetric wave systems. There's a quadruple vision system, including the FPV camera generating a quintuple security system. So the leader is issuing 300,000 laser points per second. It is great, really. It allows it to detect obstacles very clearly, and if adding an RTK antenna to the leader, we can have 3D models made too. Here we see the security system avoiding the obstacles, and we can see the cables and the columns. They're all avoided. Another innovation by DJI is the load elevation system. It can take up to 50 kilos. This is automated and safe, and I'm telling you that this is safe because there is a system avoiding oscillation, like you see the oscillation being corrected with the rope right there in the video. And also there's a proximity detector sensor for the ground. This is a summary of what we have just discussed in terms of improvement for the security system from T50 and T100, the tank capacity from 40 to 100, the solid tank from 50 to 100, the change in the flow rate, the structure of the sprayer, how it moved from an obturator to an auger, and also the speed was improved as well, and it is really spectacular. Thank you very much.
Thank you, Valentino, for your presentation. We are now going to give the floor to Matias and Diego. They are going to tell us a success story in La Pampa. I forgot to mention at the beginning of the presentation that apart from receiving all your questions or your comments, if we have time, we are going to answer them. Otherwise, we are in the stand number 70 to answer all your questions in person as well. So, Matias and Diego, you have the floor. Good afternoon. I am Diego Cunda. He is Matias Balditarra. We are from Asura, official dealers of agriculture. We are located in the center of La Pampa in Santa Rosa, and from there we are in charge of sales, training, and everything related to services for the agricultural industry, spraying, mapping, etc. So from what we do, we have first a testing of the machinery, and we have a success story to tell you about where we were able to achieve 2 types of drones of images and 1 drone for spraying. We could implement more technology to obtain an application. The case took place in the center north of La Pampa in a lot that had problems with gramón on a corn crop. So we had a green-on-green detection to have a selective one as well. The word that we use a lot nowadays has to do with efficiency, and what we are going to show you now is a case that has certain limitations. The work had to do, in a first instance, with this small drone that you see over here. Probably you have seen it before. It has a specialized sensor, multispectral sensor, with a specificity. It can see beyond what the human eye can see. So when we have a radiography or an X-ray, this sensor can help us to infer the health status of a person. So the work started first with a flight. We tried to fly over a lot of 160 hectares with this problem of gramine, or Bermuda grass it's called. So we flew 300 meters on top of the field, 8 by 8 centimeters of the field. This flight had a duration of 30 minutes. And after planning and choosing the correct sensor, we also planned the type of fly. This was an automatic fly. So we only had to monitor the equipment while it was flying. It is not autonomous. So once the drone stopped, it landed. 30 minutes later, we took the pictures from the memory card that was sent to a computer with the software, and the software had to join those hundreds of pictures taken by the drone in the lot and transform them with a technique called photometry in just one picture. And with this technique, this allowed us to obtain trustable measurements of distance, surface, and volume. Once we obtained this picture through the software, we used another software for the detection of our goal, which was Bermuda grass. From there onwards, we generated a prescription for a selective application. In this case, it was a selective application with a T40. An important detail to mention is that we didn't use the RTK antenna. So we can work with and without. We need to be aware of what is the role that we have if we don't use it and to take measures. This is a case of use where we didn't use the antenna, but we were very much aware of the errors we could obtain, and we obtained a very good level of efficiency with spraying. In this case, we didn't use it, so first we took into consideration the small drone. We had one error in the images of more or less 1 meter, 1 meter 10. Then after the application of Agras T40, we had another error of the T40 because the geoposition of the equipment was wrong. So considering the error we had when mapping, considering the error we had with equipment, the spraying equipment, and considering the speed of work and the time it took me to get to upload the target, etc., we applied this buffer to sort out these problems. And we had a very efficient work. In terms of spraying, once we have the prescription, this prescription is sent to the spraying equipment, and then we have two options: to send it to a terrestrial spraying machinery. In this case, it went to an application drone, and that's how we obtained all the information from an image drone and a possibility to do the application in real time. So what is important? What do we need to consider? Before you start, you need to have or consider several factors such as height of the flight that you can modify throughout the work, the size of the drop, the width of the equipment. That is important to measure it before, because once you start with the work, you cannot touch it anymore. In this case, we used mirrors to measure the width of the drop. And we wanted to use mirrors because we had an application with pure glyphosate. So because the cars are hydrosensible, obviously it was not going to have an impact. So that's why we decided to use mirrors, and that will allow us to see microdrops by the dispersers. And since they are very small, and even though we use water, when we throw away those cards, you cannot see the micro drops. Something important is the speed of work. Matias was explaining that the equipment needs between the asperser starts to do the centrifugate system and it gets to the target. We use an application with 4.5 liters of pure glyphosate per hectare. When the asperser starts to work,
0 a 4,5 el caudal.
starts to work, at that moment, the equipment circulates and then moves forward. So what we need to do is to use the buffer that Matias said, so that when we get to the impact, it gets with the target, which is 4 liters. So little by little, we increase the size of the buffer. You will see it in the following slide. And we have an opening in the number of hectares that we can impact. The scope of application in this case was 4.5 kilos. You can modify that, and something very important when we have a selective application are connections. In application that is full coverage, we can play a lot with overlapping, so we can work with more wind. When we have a selective application, we need to be very clear about that, because if the vortex of the equipment is moved because of the wind, then the goal is not achieved. So we are working with a wind of 5-7 kilometers per hour in average. General work, this was 176 hectares that were mapped. During the mapping, the actual hectares with widths, this is what we see over here. The actual measurement of width is 2.5 hectares of width, specific width. Obviously, when we started with the prescription, we added the buffer first because we needed to cover and see that we didn't have antenna RTK and to get to the target. So from the first instance with the buffer, out of those 2.5 hectares of width, we got to 8. So if we see 21 hectares of width, we see that we have an application of 39, almost 40 hectares. That happens because the equipment, this has been done with the T40, with the first generation. The equipment, once you open the sprinklers, covered 7 meters. When you have width in the middle, the equipment opens 7 meters when it comes and covers this part that there is no width. And when it comes back, it opens again. So from this buffer, we end up with 40 hectares. But does it work or not? Well, the total saving that we had was of a 75%. Using the whole lot with one doses, then we would have needed 75% more of product. But that is not all, because now we are talking about the hydric footprint, and administrations, they work a lot on this, lowering the IQ. So where we save 75% the product, the IQ of the lot is lowered, is reduced a lot, especially when we start to measure more the hydric footprint.
Bueno, y como para cerrar el tema,
To conclude, even though we didn't have the best level of accuracy or precision, we obtained very good results. And the success of this case has to do not only with the correct use of the technology and measure all the variables, but also the agricultural criteria that was fundamental at the moment of application. Diego, Matias, thank you very much for presenting this success story. Now is the turn of Joaco Orungo, representative in Santa Fe. I am Joaquín Longo, part of Agro team, co-founder together with my brother Santiago. This came up. The idea is to tell you about our experience as contractors. We are now talking because we started with this crazy idea of joining two passions, aeronautics and agriculture. So we started with a drone. Esteban Frola, he and another colleague offered us this idea. They said the idea is great, but go validate this because this was in its initial stage.
So after that, with different applications that we were able to do, pest analysis, natural disasters, and other issues that we cannot measure through the human eye, we incorporated drones, and through DJI drones, we could integrate applications and photogrammetry and also generate an integral solution with both tools. Today, I will show one of the latest cases that we made as Agro, as a contractor company. We take care of the country, and we try and develop solutions customized for our clients. So this is what we call today solutions with drone and techno livestock solutions. This was born as the need from a specific client that wanted to fumigate, right? We all know that the drone can fumigate or spray actually, and the small one can take pictures. Then we integrate them with the software, analyze the data, and with all that data, what do? Since we needed spraying and we had this uncertainty, why shall we spray it all, considering what the guys have just said about reducing the hydric footprint, the carbon footprint, in order to try and be more sustainable, we developed this proposal that included digitization of the property, total coverage, and we are talking about a client that bought 5,500 hectare plot of land in Entre Rios. There are many rivers near it, so it's complicated. And since it is land coverage, we wanted to control the different areas. We did the follow, and then we also were able to work on the raised banks. We wanted for this technology to give us more sustainability and traceability, and especially scalability and the repetition of these processes, because we are working on 1,344 hectares out of the 5,500 hectares of the property. And finally, we incorporate the development stage, because we all know that there are some lands that are complicated in terms of infrastructure for the weighing and sanity of the animals. You will see this at the end of the presentation. And for this, we used a T40 relay system, which repeats the signal, and we are flying fields with trees of between 12 to 15 meters of height. So we need the signal to be repeated so that we can keep our visuals with these drones. And technology will not be obsolete. It evolves, but we have the tools to defend pieces of equipment like the T40, T30, 340. Electrical generator with 3 batteries. They will last for 3 minutes of flight, and they will include also the mixer there. We have one that works quite okay from the Alamore group. and we want to maintain a homogeneous mix, well mixed. And also we have the sprinkler there for solids that comes with the drone that will allow us or help us with the seeding. All of this is done in order to have efficiency with a low investment cost. In terms of the planning, we are using RTK given the size, so with each 100 meters of the drone moving away, we see how we need the drone to control or to survey the right place. We work with these batteries that last between 25 or 30 minutes, depending on the resolution. We use a 10 centimeter pixel resolution. We fly at 370 meters of height. We also have a 2,000 watts inverter in the truck. This used 2 hours of battery in order to survey 1,344 hectares of land. And we are both certified instructors in one of the leading platforms of the market. And this, of course, accompanied by the DJI Terra system. As with the method, schedule flight, 2D route, photogrammetry with the overlapping that we are proposing. Many images I'm going to be processing in a software. I'm going to be analyzing the images with that specific software, and then I will apply AI. And something that we've been talking about a lot is AI and this technology will not replace anyone. Those that will be replaced are those that don't know how to use it, those who do not find the way to introduce it into their productive system. And spraying was by zone, total coverage, and with the following factors: initial digitalization, the renewal control audit for the pre-emergent and the fallow. There, Juan, you can play the videos. They are not in a specific order, but they are different from the new ones. So we are working with a aero applying device at 36 meters. And we have the height that I can maintain through the joystick. On the second video, you will see the audit that we conducted with Esteban, and all the works of this size are audited because the impact can be expensive and also it can have long-term repercussions. There you can see the cards with the parameters and the products that we used. And finally, there's a video showing the effective work, and this is how this works. Right there, when we have these trees, well, look at the card hidden there. We were able to have a 14% efficiency. And if you're going to be having 14 impacts in 1 square centimeter, do the exercise with a pencil and see what 14% efficiency means in such a hidden area. The truth is that this is a result of our work, but what we want to tell you is that this is because of incorporating technology, people who are experienced, and technicians, clients, and farmers open to this change, to incorporate this and take the leap. We conducted a flooded area audit because we had a lot of rain, more than 400 millimeters in 2 months. So we wouldn't do this in watery areas, and we wouldn't plant in watery areas. Then we have what happened after 18 days and after 60 days. The third one is a video, so maybe you can show the effect of the controls. This was done in December, and the planting took place in February. There you can see 5 meters above the target height with a T40, 3 generations before the one that we have today, the T100. Imagine how productive the new one will be. So how can we use the cards? I like these clips that you see on screen because we can put them in uncomfortable places and see if we are really reaching the target. And the same sort of application that we use for these small plants are used also for fallow and post-emerging plants. And we have more than 150 impacts per square centimeter. And the key for success, good inputs, both in terms of chemicals and seeds, good planning, that will come from the surveying in or with the drone. There you can see the altitude that we need given the height of the trees, and these are parameters that are going to be regulated. This is done automatically by the drone. And finally, what we have here is what I wanted to tell you about, which are cows, because our client is the cow. We want for the cow to be fed the right way and increase productivity. So this has to be useful for us, for the client, and for the cow, of course, because if not, the client will not produce, and then the cycle will be interrupted. So what we did as an extra step, and there is an application called livestock farming. We need to assess it to see whether we can quantify and weigh these outside of the areas that do not have the right infrastructure for these processes. So we are testing this right now, and probably in a couple of months we're going to be having the first results. This sounds quite promising, and the most interesting thing is that we can do this with linear consumer drones, which are not so expensive. You know, these are just supplementing drones.
Data. We flew 1,344 hectares, surveyed in 2 hours, digitalization of the entire work in high definition. We had traceability of the processes, interactive cartography with a map that we sent to our customer, all the operation programming, spraying, zonified in areas of difficult access, a very successful spraying in total coverage. I can send you the videos. They are more related to the operation. The air sowing in natural fields, where we improved half of cow per hectare to 3 animals per hectare. We intensified all the process with a lesser impact. You all know this product, we saved 87% of the product. So with the saving of that product, we could pay the work and the product. So what do we mean? We gain productivity, and every time a drone is in the air, an idea is in the air, and all these prejudices that we have with technology. So now we want to accompany you, to advise you, and to show you that with these success stories, this is something that we have been working on, so that the drones, they have their place, that you know that they work, and in the future, all the producers and advisors are going to use it. We sow to harvest. The drones, they help us to foresee that future and to feed it. So thank you to the entire team, and I am available for any question you may have. So we are going to learn a lot together. Thank you very much. Well, Joaquin, congratulations on your success story. Congratulations, it's been very original, and it contributes a lot to our network. So now we're going to have some time to answer questions that arrived via WhatsApp. We have one question from Martin that says, for a contractor, for a T100, do you have an estimate of amount of hectares of spraying? How much would be for solids? So today the T100, we don't have it available to test it. We are working with T40 and T50. We are near 80, 90 hectares per year, and on August 30 we will have it available. We are probably going to double the amount of hectares for contractors. Something important as well is that the team, with all the expenses, administrative expenses, and amortizations, interest, in less than a year you pay it back. Thank you. And then another question: in your experience, probably the two of you that are contractors, which one would be the reference rates for those projections? Well, that's quite a thing. The famous "it depends." The hectares that we use for services are development, and these are rates that are similar to an air application, and buying an application airplane is $1 million, and this is 45, 60 with entire infrastructure. So this is when we have the story of not to cover too many lots, but intensify processes and to repeat the lots and to have a comprehensive work with the drones. So it's not the same if you have 5 hectares one time or 5 hectares to have the entire campaign. Another question. How do you calibrate a drone, a Mavic 3, to improve or to be more exact with the LBI values that it provides as a result? First, you start with the target. If we are going to calibrate a drone, we need to be clear about what we want to measure, what we want to see. Based on our target, we are going to choose the sensor that we need. In the case of Mavic 3, it has an RGB sensor. With RGB, you can do a lot of things. I'm going to be more efficient. The RG sensor has 20 megapixels, different from the multispectral that has 5. Therefore, flying to have the same resolution, I'm going to be more efficient with an RGB camera, with LDB in particular. If this is for width detection, I'm going to have into consideration which is the smaller width, and based on that, define the target. Thank you, Mati. We have 5 more minutes to answer questions. If you want, you can raise your hand. No one? All right. There's one hand there. Good afternoon. I have a question concerning this. I have a question with the thesis. We are preparing the thesis. The calibration plate, Mavic 3 multispectral, has reflectance. The use, is it useful or is not necessary because it has a sensor already? I cannot see it in this case. So we have sensors that has a calibration plate incorporated. The plate allows me, in research work, to be able to compare that work with the scientific method, when you can repeat and validate. In the case of Mavic 3 multispectral, it doesn't incorporate a calibration plate, but for certain works, it is recommended in the research part to use it so it can be replicated and used with the scientific method. Thank you, Matias. Well, thank you again, the Aapresid group, for this space, for you. Thanks for your presence.